Hi, I want to walk you through the Learning Progression 5, which is all about creating scientific explanations. We're going to review what's expected. I'm going to give you some strategies and show you an example. So when you're explaining your reasoning using words, you can define physics terms and state big ideas clearly and concisely. You're proving to me that you know the material. Okay, this is where the content matters. Also, you're going to take those big ideas in physics terms and you're going to use it to create an explanation. So you have to be able to explain the ideas and apply it to specific situations. So you want to persuade me that you've learned your physics in a way that is logical and systematic. Okay? So you can use equations to create explanations, but they do not stand alone. So if you want to use an equation to explain a big idea, then you have to state the big idea first, and then you can supplement with the equation. Equations are concise and really powerful, so I don't have any problem with you using them, but you can't just say here's the equation for this for this concept, and I'm just going to look at that only, because equations are expressions of a concept or a law, and you have to be able to explain that to me. Here's the rubric. So we're going to walk through what's required for each level in order. Okay, so I want you to know, like, whatever level you're at right now, you want to focus on the very next level. So this means that you may want to pause the video and, at whatever level your target currently is at, and then wait and revisit it when you're ready to move to the next level, because otherwise this might be a little overwhelming. So I'm going to start with beginning. When you get to the level that you are that your target's at, stop the video and maybe fast forward to the end where I show an example. So if you're at the beginning level, it means you've answered the question and you explain why you answered the question in that manner. So it's not enough to say the answer is A. You have to say, why did you think the answer was A? In your explanation, you may not use relevant vocabulary. There may not be any of that in there. For developing, you are meeting all of the previous criteria, plus you are using relevant vocabulary and terminology. When I read your response, what I'll often do is circle any vocabulary or big ideas that you name. So if you say, according to Newton's second law, I'll circle that. Or according to the law of conservation of energy, I'll circle that. So you're mentioning a big idea, but maybe you're not defining it, or maybe you're defining it but not doing that correctly. Proficient is where you're correctly defining the physics vocabulary and you're stating the relevant big ideas correctly. So you must have the physics correct. However, how you apply it may have some errors in it. So for this means you've memorized the physics. So I know you've learned something, but you may still have some struggles in applying it. Maybe you're missing some logical reasoning or steps in between the physics and the answer, but at least you have the correct physics. Advanced is when you correctly explain why the concept applies in the context of the question statement, right? And I can follow your reasoning, so there's no missing steps. I think of it like it's a proof. So proofs have distinct steps that bring the reader from your beginning to the next, to the next, to the next, to your answer in some logical flow. And all of those steps need to be there to be at advanced level. You might try to pull in content from other units, which is awesome, but you may have mistakes with pulling that stuff in. Expert is where you do pull all that other stuff in and you do it correctly. It also might be an unfamiliar situation. Unfamiliar means that it might be where you're introduced to a new concept and you're trying to analyze it with given information that we haven't necessarily talked about. Okay. But everything that's in there so far is correct. So there's a strategy to this. When I do this myself, I usually, when I'm reading the problem statement or the question, I will like circle or underline or highlight the physics terminology that's already in the question because I know that's relevant. So that means I can then define those words or find a big idea that includes those words. So you could put that in. Then I'm going to figure out what that big idea is, write it out fully and completely, and then I can systematically go from that statement to the next logical piece of information to prove an answer. Okay. If I can, I will then say, in addition, I can see how this other idea applies. So we're going to do this example together. Here we go. So it says a student conducted an experiment to learn more about the transfer of energy. Oh, look at that. So there's that word, right? I noticed that right away. The student dropped 4 2-kilogram balls from rest at 4 different heights, as shown in figure 1. The student also observed that the effects of air friction were negligible. Which of the statements are true? Of the 4 balls, ball 2 will have the most kinetic energy just before it hits the ground. Of all 4 balls, ball 1 has the greatest potential energy before release. Ball 4 will have a kinetic energy of 49 joules just before it hits the ground, and all balls have the same potential energy before release because they have the same mass. So, how do we answer a question like this? For beginning level, you need to pick an answer and then explain why you think so. If you want to do developing, then you would just look at the words that are here. You see these words that are listed: kinetic energy, potential energy, transfer of energy, and use those words in your response. You might say it has ball 1 has the greatest potential energy before release because its height is biggest. So you used the words. So now let's talk about proficient, because this is where you end up really getting into the nitty-gritty. So energy is the ability to do work. Kinetic energy is the energy due to the motion of the system, and that's kinetic energy is 1/2 mv squared. So notice I put in the definition because I saw that kinetic energy was listed in the words of the problem statement and the answers. And then I included the equation, but not by itself. I included it with the definition. Potential energy is the energy due to the position of the ball, of the system, relative to some zero reference level, where GPE equals mgh. So I define that, and I put the equation. You don't have to put the equation, but you can if it's helpful. So then you could put that together. So the ball with the greatest or biggest initial height will have the biggest GPE since GPE is equal to mgh. All balls have the same mass, therefore 1 is going to be greater than 3, which will be greater than 2, which is going to be greater than 4. You don't even need all of that, but you can just simply say that B is true once you've given the reason, right? Putting that reason and setting up with all the definitions is very important. You could go on to say why the other ones cannot be true. So I didn't do these in any particular order, but statement D cannot be true because while they do have the same mass, the balls have the same mass, it doesn't account for the differences in height. That's kind of related. So then you can talk about the law of conservation of energy, which states that total mechanical energy remains constant and less work is done. I also know that work is done when an external force, like normal tension or friction, acts along the axis of motion. In this situation, there's no work done because the ball has no pushing or pulling acting on it, right? And there is no air resistance as stated in the problem up here. So therefore, you can say the initial energy is equal to the final energy, right? That's going back to here, right? Total mechanical energy is constant unless work is done. We just said no work is done. Therefore, whatever you start with, you must finish with. And we can then say, in each case, the ball begins with potential energy only and ends with kinetic energy. There is no GPE at the end because ground level is when y is 0 or h is 0. So D cannot be true because if kinetic energy final is equal to the gravitational potential energy initial, then ball 4 will have a GPE of 98, which is not the same as 49. And last, A cannot be true because if kinetic energy final equals gravitational potential energy initial, then the biggest kinetic will be had by the ball with the biggest GPE, which we already said was ball 1.